I'm going to show you how to superpose waves in Python and how to plot that. We are going to do that for here, let's say 3 waves. We can do that for any number of waves, but here we will do that for only 3 waves. 3 waves or 4 waves. So first we have to import libraries. We will use numpy, and for plotting we will use matplotlib. So first we will import numpy. From numpy we will import everything, so it will be easy for us to do the work. So from numpy import star, and we will import matplotlib for plotting dot pyplot as p, and we will set the t in a range. In a wave function we simply use t as time, so in Python we have to put t or time in a range, so we will get the value from that range. In numpy there is a function called linspace, and I will write that it will start from 0 and end at, I will set that for 2 pi. We can set any range, but I use 2 pi, and I will write 1000. So it will simply give us 1000 equally separated value from 0 and end at 2 pi. So it will give us 100 equally separated value from 0 to 2 pi, and actually we are going to put everything in here. We will put the amplitude, we will put the frequency here. So only for t we have to put the range. So let's say we are going to plot 3 waves. So the first wave, let's say x1 is equal to 2 sine t, and let's say our second wave is, let's say this time cos, the amplitude is 4, and cos, let's say 2t, and let's not take the initial phase to be 0 here, let's take it as pi. Let's say our third wave is, we have defined our waves now, and we want to plot these waves and the superposed wave as well. So for plotting we will use the function called plot. So as we have imported our plotting library as p, so we have simply have to write p dot before every function from it. So we will use plot. The plot function will simply give us the graph. So for plot, p dot plot, and we want to first plot the first wave and then the second one, we will plot everything, the superposed waves and the individual waves as well. 4. So we have set our program for plotting the individual waves, and now we will plot the superposed wave. The superposed wave is very simple actually to superpose waves in Python. We simply have to write x1 or first wave plus second wave plus third wave plus fourth wave. So it's simple, x1 plus x2 plus x3 plus x4. So that's all, nothing else. Actually we will get plot now, nothing is difficult. So to show you, we will get the plot now. After running it, we have run it, so we will get the plot here. I am using spider. This is our superposed wave. The red one is our superposed wave, this one. We have just plotted it, but it's not interesting. To make this graph interesting, we will do some work here. what we will do, as we can see, we have get our plot, and it's not so interesting, it's rather simple. So what we will do now, we will make this plot much more interesting. So for doing that, we will simply change the line width and line color and line type. This type of work we'll do now. So let's set the line width for the first wave. For line width, we will use LW, and let's say equal to, let's say, 0.9. And for the second wave also, it will simply change the width of the line, 0.9. It's Python way of changing the line width. And for the superposed wave, let's set that line width as what? Let's write 3. Let's see what is going on now. Error. Oh. What's the error? Oh, yeah. Here we have put dot. We have to put comma here. So now this is our superposed. Oh, sorry. This our superposed wave is the violet one here. It's not rather interesting. We have to change something else. We will change the color now. For the superposed wave, we will use the red color. Let's see what happens now. Red, and the line will be, and we will also change the line type. Let's see what happens. We have changed the color now, and we will let's set the label, and let's set a title for the plot now. For title, we have a function called title, and let's see the title as superposition of 4 waves. See the title. Run this. We have got the title, superposition of 4 waves, and let's set the label now. Sorry, my mistake. Let's set the label. Let's say xlabel. Xlabel as, let's say, xlabel phi of x. Along the x we have plotted the phi of x, and along t, along y, actually along y we have plotted t, the time. So let's set the xlabel as phi of x. So phi is a special character. To bring that, we have Python's way. We'll use Python's way, and that is $sign and yes, and phi. We have to write phi or 5x. Let's see what happens now. We have got 5x here. And we will now set the ylabel, and ylabel as t. Let's see what happens now. We have set the labels 5x along x and t along y. Let's make this plot much more interesting. Let's set the legend now. So for legend we have to simply label legend. We have to write legend, and now set legend label. It's Python way actually. Let's say phi of x1. So as before, phi x1. We have set it phi of x1. We have imported the legend, but we have made a mistake. Here we have to write parentheses. We have to put parentheses here. Now it will work, I guess. Let's see. Yes, we have now the phi of x1 as the legend, and it shows blue, and so this blue line is our first wave, and we will set label for our every wave. So label, we can actually copy that. I'm damn lazy to write that again. We'll copy and paste. We Bangalis are very lazy actually. Very well so. Now we have to modify these things. Here you also have x1, so we will change that as x2, here x3, and now here as x4. And let's say for the superposed, we will set it as resultant. Resultant. I think that's not okay now. We have to modify something more. We have to write these labels as in quotation mark. Let's see, now it's work, I guess. Yes, we'll get the label now. x1 is blue, x2 is orange, I guess, and x3 is green, x4 as what is that color? I don't know, and the resultant as red. Now let's summarize what we have done till now. So we have imported numpy and matplotlib, our two libraries, and we have set the values of t from 0 to 2 pi, and we have defined our four waves: 2 sine t, 4 cos 2t minus pi, cos 4t plus 2 pi, and the fourth one 8 sine t minus pi by 2. Here 2, 4, 1 and 8 is our amplitude and t as time, and for the second wave the 2 is the angular frequency, 4 is the angular frequency for the third one, and 1 is the angular frequency in the fourth one. And then we have used the function plot for plotting x1, x2, x3, x4, and we have set the title as superposition 4 waves. Let's set that as superposition of 4 waves, and the x label as phi of x, the y label as t, and we have set the legend as well, and we have used the function show to get the plot. So just a function that will show us the output, the graph, and we have set the line width of the first four waves as 0.9, and we have set the line width of 3 for the superposed wave. Till now we have worked with 4 waves. We have superposed 4 waves and plotted that. Now let's try with 3 waves. So to superpose 3 waves we have to define 3 waves, and let's try to work with our 3 new waves. We will define 3 new waves. So let our first wave be 5 sin t, and our second wave be, let's say, 10 cos 2t, let's say 5 minus 5, and our third wave be 10 cos, let's say, t minus pi by 2. So we have defined our 3 waves, and we have to also erase this line which was for the 4th wave, and we have to erase this x4 also. Let's see what happens now. So this red one is our superposed wave, and others are the x1, x2 and x3. And we can also change the color of every line. We can also change the style of the graph, and to change the style of the graph we have to do this p.style.use. And in Python there are many styles of graph, and one of those I like is called solarize light 2. This is the name of the style, and let's see what happens now. We'll run that program, and as you see the output is different now. We got a different type of graph. And let's change the value of t now. We have it from 0 to 2 pi, and now let's change it to 0 to 4 pi. Let's see what happens. As you can see the output is now very different. And we can also, we have superposed 3 waves, and we have set the title as 4 waves, so we have to change it. Now we have superposition of 3 waves as the title. We can also change the special character, which is now phi. We can change it to, let's say, psi. We want to change it to psi, and for psi we have to simply write psi instead of phi. So we will write in every place psi, psi, here also and here also. Let's see what happens now. Yes, as you can see we got psi instead of phi. Psi of x, psi of x1, x2 and x3. So it's a very simple process, and that's all.